ISRO's new mission is for the sun, but in case if you're confused, India's Aditya L1 mission is not going to the sun. The ISRO is set to launch its spacecraft to study the sun. India's first solar mission, Aditya L1, will be launched on September 2nd at 11:50 am from Sriharikota Spaceport. This is India's first ever space-based solar observatory spacecraft. The spacecraft Aditya L1, named after the sun's core, will not actually travel to the sun. It will travel 1.5 million kilometers from the Earth to the L1, or Lagrange 1 point between the Earth and the Sun. Now this distance is 4 times that travelled by the Chandrayaan missions. Lagrange points are points in space where the gravitational forces of two large bodies such as the Sun and the Earth balance out. Now this means satellites placed at Lagrange points do not need to use a lot of fuel to remain in position. Like the Chandrayaan 3 mission, the velocity of the spacecraft around the Earth will be increased till it is slingshot towards the Sun. Now the distance to the L1 point will be nearly covered in 4 months. The spacecraft will then be inserted into a halo orbit around the L1 point. It will collect data for 5 years. It is designed to provide remote observations of the solar corona, the outermost layers of the sun, and in situ observations of the solar wind at L1. The Aditya L1 mission will see the Polar Satellite Launch Vehicle (PSLV) carry the 1,475 kg spacecraft to an elliptical orbit around the Earth. Importantly, it might provide clues to scientists about a long-standing mystery: how the temperature of the corona reaches about 1,000,000 degrees while the sun's surface itself stays around 6,000 degrees centigrade. It is to get a deeper understanding of the star closest to us and how its radiation, heat and magnetic fields affect us. Understanding the coronal heating and solar wind acceleration, understanding initiation of coronal mass ejection, flares and near-Earth space weather. To understand coupling and dynamics of the solar atmosphere. To understand solar wind distribution and temperature anisotropy. The spacecraft, which will carry 7 scientific payloads, will be more than 2 times lighter than the one to the moon. First time spatially resolved solar disk in the near UV band, CME dynamics close to the solar disk from 1.05 solar radius, and thereby providing information in the acceleration regime of CME, which is not observed consistently. Onboard intelligence to detect CMEs and solar flares for optimized observations and data volume. Directional and energy anisotropy of solar wind using multi-direction observations. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the sun without any planets obstructing the view or causing eclipses. ISRO noted that this will provide a greater advantage of observing the solar activities and its effect on space weather in real time. Now, using the special vantage point L1, 4 payloads will directly view the sun, and the remaining 3 payloads are expected to carry out in situ studies of particles and fields at the L1 point. Visible emission line coronagraph is designed to study solar corona and dynamics of coronal mass ejection. Solar ultraviolet imaging telescope to image the solar photosphere and chromosphere in near ultraviolet and to measure the solar irradiance variations in near UV. Solar low energy X-ray spectrometer, high energy L1 orbiting X-ray spectrometer are designed to study the X-ray flares from the sun over a wide X-ray energy range. Aditya Solar Wind Particle Experiment and Plasma Analyzer Package for Aditya. Plasma Analyzer Package for Aditya payloads are designed to study the solar winds and energetic ions as well as the energy distribution. Magnetometer payload is capable of measuring interplanetary magnetic fields at the L1 point.